When a spark or other ignition source ignites particulate in a vessel, a fireball develops as material burns and grows at an exponential pace. The pressure front expands as the fireball grows, reaching the explosion vent. The explosion vent opens at a specified pressure, limiting the stress on the vessel and allowing it to maintain structural integrity, while also releasing the pressure and allowing the fireball to vent into a safe area outside the facility. Alternatively, when the process cannot be vented safely outside, the explosion vent opens and directs the fireball into a flameless venting device. The flames are extinguished as they pass through the flame arresting screens, allowing pressure release but preventing dangerous flames from entering the work area, protecting personnel, and preventing secondary explosions. It is also necessary to isolate the deflagration, preventing the transmission of the flame into interconnected vessels. During a deflagration, the pressure wave from the explosion reaches the detector connected to the explosion protection control panel, which processes 4,000 data points per second. The system alarms at a preset pressure level and sends an activation signal to the isolation devices. The system opens a rupture disk on an isolation container that uses 500 psi of nitrogen to drive suppressant into the ductwork, providing a chemical isolation barrier that prevents the propagation of the explosion. The system maintains a history of the event for future reference. Simultaneously, the gas cartridge actuator drives the piston on the isolation valve closing the slide gate and provides mechanical isolation which prevents the propagation of the explosion through the ductwork to interconnected vessels.